Operating system interview questions and answers. Let us take a few more. What is Gantt chart? Gantt chart is represented like this, in which you have various activities and time. So two-dimensional chart that plots the activity on the y-axis, means this axis, and the time on the x-axis. The chart quickly represents how the activities of the units are serialized. Define deadlock. A process requests resources. If the resource is not available at that time, the process enters a waiting state. So the waiting states may never again change state because the resources they have requested are held by other waiting process. So we have a waiting process because it is waiting for some resources. Now some process has come. It is expecting or waiting for a resource. Now because it is not getting resource, it will again go to waiting state. So now this process and this process, they both are waiting for the same resource which is held by some other. Okay, this is the deadlock condition. The situation is called deadlock. What is the sequence in which resources may be utilized? What is the sequences in which the resources may be utilized? So under normal mode of operation, a process may utilize a resource in like this. First is request, that is if the request cannot be granted immediately, then the requesting process must wait until it can acquire the resource. Then it uses, that is the process can operate on the resource now, and then when the work is done, the process may release the resource. Next question is, what are conditions under which the deadlock situation may arise? So you need to know those situations where the deadlock situation may arise. Can you answer this? The answer is 4 conditions are there. So a deadlock situation can arise if these conditions which I am going to tell you hold simultaneously. They have to hold simultaneously. That means at the same time in a system. That means we can infer that deadlock has occurred. First is mutual exclusion. Second is hold and wait, no preemption, and circular wait. What is RAG? RAG is resource allocation graph. What is RAG? Deadlocks can be described more precisely in terms of directed graph. Okay? Directed graph called as a system allocation graph. So this graph consists of a set of vertices V and a set of edges V. So the set of vertices V is partitioned into 2 different types of nodes. P is the set of consisting of all active processes in the node, and R is the set of consisting of all resource types. In this, you have a process, you have a resource. If the resource is allocated to the process, we do like this. And in this form, we make a graph. Define the request edge and assignment edge. The way I showed you just now, it represents the request edge and assignment edge. I'll tell you. A directed edge from process Pi. See, this is process Pi. A directed edge from process Pi to resource Rj is denoted by this. Signifies that the process Pi has requested an instance of Rj. Pi has requested instance of Rj and is currently waiting for that resource. A directed edge from Rj to process Pi is denoted by this one. This one. It signifies that the instance of process resource type Rj has been allocated to Pi. So a directed edge, this is called the request edge. See? So a directed edge which is of this form is called an assignment edge. This is assignment edge. This is request edge. This is the assignment edge. What are the methods of handling deadlocks? How can you handle the deadlocks? There are various methods. Can you answer? The deadlock problem can be dealt in 3 ways. So there are 3 ways of dealing with it. First, we use a protocol to prevent or avoid deadlocks. We use a protocol to prevent or avoid deadlocks, ensuring that the system will never enter a deadlock system or state. Then we allow a system to enter the deadlock state and we detect it and then we recover. Third idea is, or the scheme is, to ignore the problem altogether and pretend that the deadlock would never occur in the system. And most famous operating system, they use this third one only. Define deadlock prevention. What is deadlock prevention? Deadlock prevention are the set of methods for ensuring that at least any one of the 4 necessary conditions, which are mutual exclusion, hold and wait, and no preemption and circular wait. So these are the 4 conditions. So at least one of these 4 should not hold. So by ensuring that at least one of these conditions cannot hold, the occurrence of the deadlock can be prevented. This is deadlock prevention. Now what is deadlock avoidance? What is deadlock avoidance? See, this is an alternative method of avoiding deadlocks. This is to require additional information about how resources are to be requested. So each request requires the system consider the resources currently available, the resources currently allocated to each process, and the future request. So what a process would intimate that what resources it is going to use, and releases of each process to decide whether this request could be satisfied or it must wait to avoid a future deadlock. This is deadlock avoidance. What is a safe state and what is unsafe state? A state is safe if the system can allocate resources to each process in some order and still avoid a deadlock. Allocate and avoid the deadlock. So a system is in safe state only if there exists a safe sequence. We're talking about a sequence, how to allocate, in what sequence. So a sequence of process from P1 to Pn is a safe sequence for current allocation state. If for each Pi, the resource that Pi can still request, can be satisfied by the current available resource, plus the resource which are held by Pj, where j is less than I. So if no such sequence exists, then we say that the system is in unsafe state. What is Banker algorithm? What is Banker's algorithm? See, this is algorithm in general sense. The bank should have at least that amount of money so that it could satisfy all the customers. So Banker algorithm is a deadlock avoidance algorithm. Please understand, it is a deadlock avoidance, not prevention. Prevention means just withholding just one condition, at least one condition of the four simultaneous condition of the deadlock. But here this is the deadlock avoidance algorithm that is applicable to resource allocation system with multiple instances of each resource type. So the two algorithms which we use is safety algorithm, that is and the resource request algorithm. Safety algorithm is the algorithm for finding whether a system is in safe state or not. Resource algorithm or resource request algorithm, if the resulting resource allocation is in safe state, the transaction is completed, and if process Pi is allocated its resources or not. This is resource request algorithm. If the state is unsafe, Pi, the process must wait, and the old resource allocation state is restored. Define the logical address and the physical address. What is the logical address and the physical address? The answer is an address generated by CPU is the logical address. An address seen by the memory, that is the one which is loaded into the memory address register, MAR, of the memory, is known as the physical address. Let me detail you again. Address which is CPU generates some address. So what CPU generate is a logical address. But the actual address seen by the memory, that has to be loaded into the memory address register for actual picking up or storing, is known as the physical address. What are logical address space and physical address space? The set of all logical addresses generated by the program is called the logical address space, and the set of all physical addresses corresponding to these logical addresses is physical address space. What is the main function of the MMU, Memory Management Unit? What is the main function of MMU? See, the running mapping from the virtual to physical. Virtual to physical address is done by the hardware device, which is called the Memory Management Unit. What are the methods for dealing the deadlock problem? What are the methods for dealing with the deadlock problem? First, we use the protocol to ensure that the system will never, we have already seen it, but this is an important question, so I'm repeating it. Use a protocol to ensure that the system will never enter a deadlock state, allow the system to enter the deadlock state and then recover, ignore the problem altogether and pretend that the deadlock has never occurred in the system. Now define or differentiate the deadlock and starvation. Deadlock and starvation. So this seems to be, very much related, the words, but they are different. A set of process is in deadlock state when every process in this is in the set of waiting for an event that can be caused only by the other process in the set. But starvation or indefinite blocking is a situation where a process is waiting indefinitely within the semaphore or waiting for some other process to complete, which is not completing. Then what are the system components of operating systems, and you need to explain them. These are the system components or what operating system is dealing. Operating system deals with process management, main memory management, file management, input-output system management, secondary management, networking, protection system, and command interpreter system. Define system call and write about the various system calls. First of all, there are various types of system calls: process control, file management, device management, information maintenance, and communication. We'll talk about this later. Later questions. What is a process? Explain the process control block and various process state. See, a process is a program under execution. So, operating system execute a variety of programs. These programs could be batch systems like jobs, time shared system like user program or task. So there are various textbooks which uses the job and process almost interchangeably. But the process is a program which is under execution. So process execution must progress in a sequential manner or fashion. So what a process includes, that is a PCB, that is a context also, we call them context also. So process control block, they have program counter, stack, data section, process state, register state also. And what are the various process states? So the process can be new, that is the process is being created, or running, that means the process are being executed right now. The waiting is the process is waiting for some event to occur like input output, and ready means the process is waiting to be assigned to a process or to processor. And the terminated means the process has finished its execution. Explain the term process creation and process termination. Process creation and process termination. So process creation means parent process which creates child process, which in turn create other process. So this is a process like this. It creates this, it creates this. It's forming a tree of processes. This is a kind of tree. So process, they do resource sharing. Parent and child share all resources. That is, child shares subsets of parent resources also, and parent and child, they may share no resources also. So in execution terms, parent and child execute concurrently. Parent waits until child terminate. And in address space, they share the common address space maybe, and child duplicate of a parent can be formed and child has a program loaded onto it. So process creation means creating a process. Process termination means termination of a process. But when your child process is there, when you terminate, all those processes the child has created will be gone. For example, in Unix, fork system will call for a new process. So call for new process. exe system call, this is used for or after this fork to replace the process memory space within a new program. So what about process termination? Process execute last statement and ask the OS to decide it, that is to exit. So output the data via or from the child to parent. This is via wait. And process resources are deallocated by operating system. So parent may terminate execution of the child process, as I just suggested. So child has exceeded its allocated resources maybe, or task assigned to child is no longer required and the parent is exiting. So operating system does not allow child to continue if the parent terminates. Talk about inter-process communication, that is IPC. First, we need to tell about the IPC, then the message passing system, the naming, the direct communication, the indirect communication, the synchronization, buffering. So there are various things you need to talk about. But let me tell you that the message passing through one process to another is done through IPCs, inter-process communication. Now you have to write about various CPU scheduling algorithms. There are various CPU scheduling algorithms because there are various processes which are there, and when number of processes are there has to be scheduled. So we need to answer in this manner. First of all, we can say that we need this optimization criteria. For that, we need the CPU scheduling algorithm. It has to be optimized, efficient. For this, there are various scheduling algorithms. First come, first serve, FCFS, shortage of first, SJF, priority scheduling, round robin, multi-level queue, and multi-level feedback queue are used here, right? Explain the classical problem of synchronization. There are various problems of synchronization because once there are various processes which are executing, now you don't want the data to be inconsistent when some critical region is being written. So there are various things which are done by the synchronization process. There are various classical problems of synchronization: bounded buffer problem, readers and writer problem, and dining philosopher problem. So we